Welcome back. In this video, we're going to talk about how to solve a linear equation. So before we get to solving, let's just talk about what a linear equation is. This is an equation with one variable where the highest power on that variable is a 1. So we're not going to have an x squared or any other higher exponents. We're just solving for the one variable itself. Because we're looking at an equation, we're only going to have that one variable, whatever it happens to be. To solve for that variable, we're going to go through the steps to isolate it, right? That's our goal. And so we may need to add or subtract from both sides. We need to multiply or divide from both sides. There are three types of equations that we could run into. Most of the time, we're going to be solving what's called a conditional equation, which is an equation that has a specific solution. So in the case of a linear equation, we're going to have one number as our answer, right? And that's our specific solution. However, there are some equations out there that could fall into the second two categories, first of which being the identity. If it's an identity, basically that just means that both sides of the equation are equivalent, which means that no matter what number we plug in for the variable, we're always going to have the same value on both sides. And so we would say that the solution is all real numbers because any number would work. The last option is what's called a contradiction, and this means that no matter what number we put in for the variable, we're never going to get the two sides of the equation to be equal, and so there is no solution, no number that works for both. All the examples I'm going to give you today are conditional equations because that is what we're going to work on in our class. So here's an example. All right, we're going to be just solving symbolically today, which means we're going to be kind of maneuvering the variables and trying to combine like terms and move things from one side of the equation to the other to get the variable by itself. So can you think about what we might do first? The first step for this problem is to maybe remove some of these parentheses. So we're going to distribute the 4. We're going to distribute the -2 over here. And then this negative, right, think of this like a -1 out front. So we're going to also be distributing that negative as well. So maybe we could do all three of those things at the same time. So this is going to give us 4y plus 4. This will be a -3 or -3, and this negative times a negative will give us a positive 5y. And then we'll have -2y plus 4. Okay, so maybe on the left-hand side we want to combine like terms. So we've got 4y and 5y. That's going to make a 9y. We've got a positive 4 and a -3, so that's going to give us a positive 1. Now we'd like to get all the y's together on one side, so I am going to add 2y over to the other side. So that's going to give me 11y. All right, you could probably have done this in fewer steps maybe, but I thought I'd break it down today. All right, so then we're going to subtract 1 from both sides. And to get y by itself, right now it's multiplied by 11, so we're going to divide both sides by 11. All right, and here's our final answer. And it can be a fraction, and that's okay. Usually, if you have whole numbers in your original equation, then you can choose fraction or decimal. This one doesn't look like it would turn into a very nice decimal, so we'll leave it as a fraction. But if you had fractions or decimals in your original equation, usually we would kind of stick with the same. So if I had fractions in my original equation, I would write my answer as a fraction. All right, let's try another one. So there are some strategies that you can use to work these out. So I want to demonstrate 2 of those strategies for you. These aren't the only things that you can use to solve these equations. You could definitely go a different direction if you wanted to, but I just wanted to kind of showcase these 2 in case you were interested. So one of the strategies is that we can multiply by a power of 10 if we have some decimals. So if I look at all the decimals I have here, this one, and this one, I only have 1 digit after the decimal, right? So if I multiply by 10, that'll move that decimal 1 place over and give me a whole number. Some people like to do that, okay? So we're going to do that. We're going to multiply both sides by 10 itself, right? This time we're using 10 because of that 1 digit. If we had 2 digits, we'd use 100. If we had 3 digits, we'd use 1,000, and so forth. All right, so I'll just write it like this, right? So we're going to multiply this term by 10. We're going to multiply this term, right? It all goes together, so we're just going to multiply it once by doing it in the front. And then we're going to multiply this term by 10. So that's going to make this 2y. That's going to make this 3 times 5 minus 2y. Right, and since this is all multiplied together, we only had to do the 3 out front. And on the right-hand side, this will become negative 2y. So now the decimals are gone, and I can work it out. Maybe that's a little easier to look at. Or maybe you like the decimals, and that's totally fine. You could just work with the decimals. You're welcome to use a calculator, so whatever your preference is, I just wanted to show you this method. Okay, then we would distribute like we just did, combine like terms on the left-hand side. Then we want to get all the y's on one side and all the numbers on the other. Since I only have the number 15, it might make sense to move my y's over to the right this time. So I'll do that by adding 4y to both sides. And then instead of 2y, we'd rather have y, so we're going to divide both sides by 2. And since my original problem had decimals, I'm going to go ahead and make this into a decimal. So if I divide by 2, I should get 7.5. All right, so that's one strategy for decimals if that's something you're interested in. This next problem has some fractions in it. And so one way to deal with fractions, or to kind of, it's the same kind of idea, but the way to sort of wipe out the fractions so that you can work with whole numbers would be to multiply by the least common denominator. And I probably should have left this blank, but if we look at all 3 denominators here, right, we want a bigger number that all 3 of these go into evenly. And yeah, I should have left this blank so we could kind of fill that in, but 6 is the smallest number that works that way, right? 3 divides evenly into 6, 2 divides evenly into 6, and of course 6 divides into 6. Now, could you use something bigger? Absolutely, right? 12 would work because it's divisible by all 3 of these numbers. I don't know, 24 would work, 18, right? But 6 is the smallest, and that keeps the numbers a little bit more manageable. So I'm actually going to write this one out. We're going to multiply each term by 6. And since we're dealing with fractions, I'm going to go ahead and write it as 6 over 1. Okay, and when I do this, some really nice canceling should happen if I've chosen my number appropriately, right? So I would recommend dividing these out first. That'll make your math a lot easier versus multiplying it and then dividing it. So 3 goes into 6 2 times. So this becomes 2 times k plus 1. 2 goes into 6 3 times, so this becomes minus 3. 6 goes into 6 1 time, so this just becomes 3k minus 3. All right, so clearly this is a lot easier to look at to solve, I think, probably than all these fractions, right? So now we can continue doing what we've been doing for the last couple examples. We'll distribute. We'll collect like terms. Then we want to get all the k's together on one side. Since 3k is bigger, I'll go ahead and subtract this 2k over to the right. And 1k or just k would be the same, right? And then I want to get it by itself, so I'm going to add 3 over to the left. And so it looks like I turn out with k equals 2. All right, so this is very handy. This is something you'll see again in college algebra. So it's really a nice, I don't want to say trick, but strategy you can use to multiply by the least common denominator. All right, one more example that came from this section of the textbook. Uses this solving to solve for different parts of the equation. This may be stuff that we did in the last chapter, but it's a good place to revisit it. So to find the x-intercept, this is where we set the y equal to 0 and find x. And the y-intercept, this is where we set the x equal to 0 and find the y. Okay, maybe we should just take a quick second to explain why is that, right? Okay, so if we have a line, let's make one up. The x-intercept is the place where we touch the x-axis. So we'll have a number for the x value, but because we're on the x-axis, we didn't go up or down at all. So the y value is 0. And then the y-intercept is on the y-axis, and we have a number for the y value, but we haven't gone left or right, so we have x to be 0. Okay, so let's use that to solve for the other variable. So for the first one, we'll have 2x minus 3 times 0 equals 9. Some people like to do what's called the cover method, where because the y is 0, you could just cover up that term because it's going to multiply to be 0, right? So we end up with really just 2x equals 9 because this is 0. We'll divide by 2. And how about we make it into 4.5? So the x-intercept really is the point 4.5, 0. We could do the same thing for the y-intercept. Now we're going to let the x be 0. Again, we could sort of cover this up and continue solving because this part is going to go to 0. So really that's negative 3y equals 9. And if we divide by negative 3, it's going to give us a y value of negative 3. And really this is the point 0, negative 3. Okay, so that's kind of one way we could use our solving to kind of tie into a line or equation of a line. Another way to do that is to be able to take this equation and solve for y. So we're still using the same type of equation solving skills, but we're just isolating one of the variables even if we don't have a number for x. And that's going to be useful as well. So if this were a number, we would subtract it over to the other side. It's not a number, but we can still use that same process to rearrange the equation. And it's pretty common to put the x term in the front when you're talking about an equation of a line, so I'll do that here. Although they didn't really specify, so you could put it in the back if you like. And then we don't want negative 3y, we just want y. So we're going to divide both sides by negative 3. And the negative 3 is going to divide evenly, well, not evenly, but it's going to divide into both pieces, right? So negative 2 divided by negative 3, the two negatives are going to become positive, and we're going to have 2/3 x. 9 divided by negative 3 would be a minus 3. And notice this sort of ties in with what we got for the y-intercepts. It's negative 3, and the value for b is negative 3. All right, well, I hope that gave you a good explanation on solving an equation with one variable. The next video, we're going to look at some word problems where we write an equation and then solve it using the strategies we just talked about. Good luck out there.